Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 9, 2025, which was about 11 days ago. The standout finding is that even top systems falter at multi-reference conditioning, with OmniGen reaching only 66.6% on synthetic samples and 79.0% on real-world cases against the golden answer. The paper is titled, MultiRef, Controllable Image Generation with Multiple Visual References. And as we will see later, the implications for creative tooling are quite significant. Beyond benchmarking, the work introduces RefBlend and builds MultiRef, a 38,000 image dataset, to drive progress on multi-source controllability. Alright, this figure contrasts single reference generation with multi-reference generation. The top row shows text-to-image and image-to-image attempts that capture one constraint but miss others, which is why the neutral faces appear. The bottom rows then combine several cues, like a Monet color palette, the Eiffel Tower shape, and a hand-drawn sketch to produce a coherent scene. A second example swaps Franklin with nachos on a dollar bill, illustrating precise, multi-source control. Building on that, this figure shows the RefBlend pipeline from raw image to finalized training sample. On the left, references like canny edges, depth, masks, and subjects are extracted and filtered, which creates a pool of compatible visual cues. In the middle, the system selects a set of references, writes a basic instruction, then enhances it so the prompt explicitly ties to each reference. On the right, the enhanced prompt and linked images are packaged into a multi-ref sample. Next, this table lays out the reference compatibility matrix, which tells us which visual cues can coexist, which ones depend on others, and which pairs are forbidden. You can see green checks for feasible pairs, red crosses for conflicts, and arrows for dependencies. Notably, masks and bounding boxes require a caption or a subject, because those spatial hints must point to a named object. Style and caption are universally compatible, while global structure cues like depth and semantic maps avoid overlapping with each other. Now, this table summarizes real-world performance across tasks like element addition, spatial manipulation, element replacement, attribute transfer, and style modification. Scores are split into image quality, instruction following, and source fidelity, which lets us see where systems fail because high quality can hide poor adherence. Unified models cluster mid-pack, with OmniGen strongest overall but still trailing on fidelity. Compositional setups with a perceptor and a generator push image quality higher, yet they often drop instruction following and fidelity. The ground truth row anchors the upper bound. Wrapping up, two takeaways stand out. Multi-reference conditioning remains hard, since even the strongest model tops out near 70 to 80%, and the new benchmark plus RefBlend and MultiRef give a clear path to improve instruction following and source fidelity. Thanks for joining. This is Alex, and you've been listening to the AI Research Roundup.